All right, so I'm going to say a few words of our very generous sponsor, and I'm saying generous for having pulled this event together and also for having named me CEO. So for the 2 or 3 people whose faces I haven't seen here before, we are Tryolabs, probably the company name with the most amount of misspellings ever. Yeah, it's like we have a Slack thread with like 30, 40 different misspellings that people make. So yeah, we are an AI consulting and services company, so we help companies accelerate adoption of AI. So that means that we partner with companies that have data science teams and make them better, and we partner with companies that don't have data science teams and work on data science related initiatives. So we can work on everything on the AI journey spectrum, let's say. So everything from generating awareness, kind of strategy, roadmap, and then doing POCs to show value, interacting with different stakeholders, getting in touch with the data, getting buy-in from different people in the organization as of these initiatives, then productionalizing those POCs and scaling them. We also like to act as the kind of ambassadors of good practices of AI applied in the industry. So kind of the center of excellence for companies willing to take their data science teams to the next level. And finally, we like to help clients create internal capabilities because we want clients to want to work with us, not to need to work with us. So yeah, super excited to be here. We are early in the game. We started back in 2009, 2010, so way before AI was cool or Gen AI was even a thing. And now, yeah, we have historically worked for startups here in the Bay Area and moved up the ladder. And nowadays, we're partnering also with some other larger firms, some of which are here. So Numenta, the RealReal, are some of our customers I'm going to be speaking today. So yeah, what we want you to take out of this event, apart from the delicious snacks and the beautiful view, and the great presenter here, is a space for networking and meeting like-minded folks in the AI space. And yeah, also insights from our speakers today. So first, I'm going to announce something for tomorrow. So we're doing a lot of events this week, and we're doing a webinar together with Google. And let me explain a little bit what this is. So anybody that has worked on time series, time sequences data with Python should be interested in this. So we are building a library together with Google called Cheriyan. And the library is for basically pre-processing and feature engineering of temporal sequences data. So whenever you do work with, think of pandas as kind of the go-to tool with the data frame for the data science ecosystem in Python. So pandas is like super generic, you can do whatever you want in pandas. Cheriyan is like pandas, but very, very narrow on a data structure that will help you do work with time sequences. So, so for that niche, you go to Cheriyan. So it's faster than pandas in many ways, and it will also give you like operators that you can chain to do all these pre-processing of the temporal data. And every operator will kind of prevent you from making common mistakes that with pandas are easy to make. For example, leaking future data to the past and some others. So I'm going into some detail because I know that we are all nerds here. So yeah, please join tomorrow if you can make it. It will be 10 a.m. actually, San Francisco time. If you can make it, like we'll put up the recording this week. All right, so with that said, without further ado, let me introduce the first speakers today. So Soledad, tech manager, dear friend and MLOps engineer at Tryolabs, and Chris, former VP of data science at the RealReal. And they're going to talk about how the RealReal leveraged AI throughout their journey. So welcome, Chris and Soledad.
Today.
Great.
Okay.
Good.
No, I'm not feeling so much excitement. How are you feeling today? Thank you. So today, as Alan already presented me, I'm Soledad. I'm tech manager and MLOps engineer at Tryolabs. I've been working at the company for 7 years now. I have background in software engineering, so going through MLOps was like really natural in so many ways. Today I'm thrilled to have Chris here, that is a proven AI leader. Please.
Hello everyone, thanks so much for...
Hello everyone.
There we go. Yeah, thanks so much for having me today.
Okay, so a little bit on the Chris background. He's a proven AI leader who has driven data transformation across retail and other industries. We have worked together with a couple of years, and I have seen transitioning from the really technical details on how building AI pipelines and discussing the things throughout the journey to becoming a BD. So it was a pleasure to be part of that journey. So the idea today is to have like a fire chat mode, and we have the first question here. And the first question is, you have an impressive track record at the front of impactful AI initiatives. So what strategic insights have shaped your leadership journey?
Yeah, it's a great question. You know, when I think back to when I started at the RealReal, which was about 5 years ago, prior to when we worked together, which was the last 2 years, and you saw some growth then. I think I learned about how to be strategic probably the hard way. I came into the RealReal and I inherited maybe six engineers working across 2 projects, and we scaled up in the first 3 months to 12 engineers working across 4 projects, and then by 12 months maybe we were at 20 engineers working across 7 projects. So what worked at the scale for 5 or 6 was more like a tech lead kind of manager, did not scale to 20 quickly, and I really had to think through the first strategic path was, what do I focus on and what don't I focus on? And scaling that up was a challenge, and I was working kind of 80 hours till I kind of made that switch, and I had to say, like, okay, well at this point, what's the biggest value that I bring to the org and my team? And it's not so much getting in the details of the code, doing PRs, which I did for quite a while. It was more about, you know, getting the right team, getting them organized, getting them moving in the right direction, just basic leadership things that you can develop being a director over several projects. And that was really important, and to, you know, enable the team and, you know, build them to the point where they were doing the things that I was doing and trust and verify. So I would say that was probably the first thing that kind of came to me. The second thing that I think is kind of really important when I think about building successful products is thinking through a basic product management lens. So what is the vision of the product that we're all trying to build, set us in the same vision that we're going to get to the theme of like what this thing should do, and then kind of going a layer below and saying like, how are we going to measure that? So whether it's like click-through rate or something else, and that kind of sets up like the end state. So if I think about the end, if we're going to run an A/B test, there's going to be this metric that we have to optimize the variant over the control. And if you don't choose that correctly, and you get to that end state, you build a whole model, and you have the wrong variable, you have to go way back and redo it. So that's not always the greatest path. And then once you have that, it's kind of like, how accurate is the system today? We've learned a lot of times through, you know, when we're at the RealReal, when we're dealing with human processes, that not every human process is 100% accurate. And when you go in with that assumption, then maybe our stakeholders will tell us, no, it's this, without verifying the data or doing a double-blind study. You can do a lot of spinning, so it's a good thing to always verify that. And then once you kind of have that product template and that outlines what success is, the team is kind of unleashed and able to kind of build multiple scenarios and multiple things that can accomplish that goal. And then you don't have to be the one that's pushing forward, solve it this way, but really letting the team solve it through multiple different channels. And then I think the last one that kind of sets it up for the team is getting a good metric to verify is how quickly can you go from that idea and POC to the first deploy in production. Because that first deploy will help you validate where all those kind of metrics that you did while planning, were they the right metrics? Were they the right evaluation criteria that maps to that metric, the right test set that kind of sets up that simulation of that A/B test that you're validating offline, and they're all kind of all chained and connected together. So I think those are some reflections that I had about the strategic initiatives.
Yeah, no, really complete answers. Thank you very much for that. For example, on the technical side, you're a really technical person in many sense. But how did you manage to combine the technical knowledge with your fast to leadership and communicating with other non-technical stakeholders?
Yeah, that's a great question. You know, when a company like the RealReal, which is not inherently technical, there's a lot of people that are, you know, they think from the business perspective, and tech is an enabler. And they don't want to get into the details. The more you can show, keep it in headlines and show like the value through data, through tests. That's what we've often leaned on to just show and tell rather than kind of talking hypotheticals. But I do think it's really important to still manage perceptions and fears because people, organizations are made up of people that make subjective decisions instead of maybe just the way we think as technical leaders where it's always like it's a hypothesis and you test it. It's more about managing emotions.
Yeah, totally agree on that. Given your recent experience in retail and e-commerce, where does AI create the most value?
Yeah, that's a great question. I think it really depends on the business model of the company. So if we think about in terms of retail, there is, when I think about a one-sided market, direct to consumer, where your inventory comes from a supplier, a lot of focus is often on marketing, because I was at a whole company where marketing kind of made the demand that generated the revenue and the profit. And how you can get that kind of incrementality about your marketing channels, how you optimize the marketing spend is pretty common. Similarly, there's a lot where it's like pricing, where you set the price, you're able to optimize on it. And often that optimization, like a 1% increase in price, trickles pretty much down to the bottom line directly. There's also personalization, which many retailers are kind of involved with. At the RealReal, we were something kind of special. So we were a two-sided marketplace where we had to get our supply. So it wasn't always that we had a supplier, we could just call up, hey, give us more of these widgets. We had to call individual people to get them. So we focused a lot on how do we acquire those individuals. And then once it showed up at our warehouse, this is where we focused on the most was how do we annotate all that information about the products. So it's not something like eBay where you're listing the product, describing it. You're taking a picture of it as a seller. That was a turnkey operation for the RealReal as a value add. So we did a lot of that with machine learning, with partnership with Tryolabs, where we would, instead of writing a description like people would for 20,000 products a day, we would use the image and automatically generate all the descriptions. We would take a photo instead of manually cropping, editing, and aligning. We would digitally retouch it, and that was about over 100,000 images a day. So we did these things at scale, and we also, on the buyer side, you can imagine buying a Rolex watch at RealReal. You don't want to take on that risk of like, what is a bad actor if it's fake? So we did a lot of authentication, and that was really core to the business because it's in the name twice, the RealReal, right? So we had to be pretty well accurate, and there was a lot of risk if our ML model made a mistake. So we had to kind of balance these trade-offs, and it was very challenging but very rewarding. We ended up submitting several patents in the process, which was really cool.
It's cool indeed. And one follow-up question to what you were saying. I know that you are a really analytical person and data-driven, as you were saying before, also for having non-technical conversations with other stakeholders. We have estimated efforts, impact, and defining KPIs for improvement. So in this process of the warehouse that you were mentioning, how do you identify like the use cases or the best use case for automation?
Right. So we had a couple of different sources of imperfect information that we would use to try to rank what would be the highest thing to go after. A lot of these were kind of studies from years ago where they would time estimate how long it would take people in the warehouse to do a task. And that was kind of back of the napkin, estimated to a cost per doing this task per item. There's so many items a day, there's so many people that had to do this item, here was the total cost, here was the time estimate of what it was. But it was often imperfect, it was not the best. We also sought to try to do better. Like how can we, when we think about like clickstream and you're visiting a site, you can capture every event that happens along the way. So we often discuss like how can we perfect it, because we're making a lot of big decisions based upon this time study. And then we would get into production and then we would not realize some of the gain, or sometimes we would realize like way more of the gain, which was great, but it was like how do we close that variance gap off earlier. So we try to do some other methods where we capture more data, but often we just kind of lean back in on this time study and try to do the best we could with it.
Yeah, definitely. And in this that you were saying that sometimes the outcome is somehow unexpected or is uncertain in many ways. It's also this flexibility that you may have to change scenarios really fast.
Yeah, I think there was a lot of dealing with ambiguity at the RealReal, especially in the roadmaps. We had, when we made the transition to profitability, especially, we had to be cognizant each quarter and prioritize ruthlessly about what was the highest impact thing to go after. And sometimes what we'd do, we'd have to make short-term decisions to kind of get back on track to get to this profitability goal by the end of the year. And it was challenging, especially with something like machine learning projects that could span multiple quarters. So being nimble and quick and kind of getting that first value to production was super important organizationally to get those initiatives bigger buy-in, to get bigger success. And that's kind of what we really leaned in on as a major metric for the MLOps team when we think about managing MLOps like a product, like our ML engineers or our users, how do we solve their pain points? And a lot of that was to try to get from POC to production as quick as possible to kind of get that business value and try to increment from there. Because we saw the MLOps team as a real multiplier for the rest of the org.
Yes, and like the connection between all the different cases, different companies. What were some key lessons learned on moving pilots to production?
Right. I think this one kind of coincides with tech debt. A debt is something you take on for a short-term impact, but you have to pay it off later. It has a long-term implication. So depending on where you are in the life cycle, I remember when we came in and we had the three biggest projects at the company, they were all ML related. We had copy automation, retouching, and pricing. We took on some tech debt and let the teams kind of go independently to try to get value as quick as possible, knowing that we'd have to come back and kind of adjust it later. But the future was so uncertain that it made sense to take on that debt for the short term. But in the long term, it did cause us some work, right? We had 3 different ways that we were serving these models in production because they were boutique solutions that the people on the independent teams knew the best, that they could get out the best and deploy the best. And that comes with a trade-off for sure. And then as we become more mature, we want to standardize some of this tooling across. So then we thought later on, like, how do we really set the standards? Like, these are the frameworks that we want to implement and are approved, and set some governance up. Because when we set up with this microservice pattern, you could go completely the opposite way and say, like, hey, a team, if you know a team is going to be there forever and they're always going to have a team to manage their services, you can go that other direction and let.
Yeah, you rely on them. Yes.
Right. But in our case, we had a lot of fluidity on our team size that was dependent on getting on the path to profitability. So we chose the path of standardization, and it allowed us to ensure that we had better maintenance overall. Because if you set up a new person that comes on a team, they have a framework in mind, they want to use it, and then before you know, you're managing that framework for all the time, whether none of the rest of the team uses it. So it's a pattern you want to avoid a little bit.
Yeah, that takes a lot of coordination between teams, and also setting expectation and all of what Chris just mentioned is a challenge, but I think you did the right call. And also about talking about enterprise. What are some? What are some unique challenges of rolling out AI at the enterprise scale, and how have you overcome those?
Yeah, I think there's two main challenges that come to mind. One is when I think of enterprise, I think of scale and engineering terms. So you have queries per second that you could have a service kind of respond to. And there's a couple ways to handle those. We really leaned into the stateless, serverless approach. So we rely on the cloud to help us scale. We try not to take on too much state, so each independent function can scale concurrently. So we take on thousands of requests, and we implement it the same way for a few requests, those thousands of requests, and it doesn't have a huge impact. We also try to go after a async design where we can versus sync. That also allows scale a little bit better. It depends on the use case. And we're able to partner with Tryolabs that has both the engineering skill set as well as the ML skill set, create a squad that can maintain and build out deploy the services. The other side of when I think about enterprise is like a lot more people. A lot more people have a lot more opinions, and that becomes a thing to manage as well. We found ourselves in my growth through director to VP, just as like when you go from tech lead to manager and director, when you're a tech lead, you think more technical, and you're like, well, people management isn't necessarily a full-time job.
Mm-hmm.
You go into that, you're like, wow, that's a huge job, right? And as you go from director to VP, you're like, well, the managing people's perceptions, managing people's fears and emotions around projects, like that's only part of the job, and then you learn again and know that's a full-time thing. So I think it's like really important. There are several perceptions, especially on a non-technical leadership team, about like, what could go wrong. I might hear a different approach from some other vendor. How do we manage that perception about what is going to be successful and not?
Yeah, totally. And regarding to what you were saying, managing the change, and not only people, but also the projects. We were working on MLOps before the term was even popular. So that was a challenge too, because we kind of had to learn throughout the way. How do you think are the key skills that a team must have for tackling those type of projects?
Yeah, I think it's still a challenge today that there's not one well-defined way to do it. When we're at the RealReal, we were managing going from completely AI product to no MLOps team, and then slowly migrating things to an MLOps team. And we couldn't just steer and say, what's the optimal ratio of MLOps to AI product.
Mm-hmm.
We had to slowly migrate over to. And I think it's, its core MLOps is just solid engineering principles applied with machine learning, right? The way we managed it was we built this SDK, and that helped us kind of abstract the ownership at an API level, but it's also kind of at a team level too. What is the team responsible for that AI product versus the MLOps,
Mm-hmm.
and then how does that technology coincide with that ownership, and then how do you build processes around that? We ran into a few different challenges. People get very passionate too about the tools they want to use because they know it for right. So and you have to balance how do we ensure this long-term maintainability, traceability, reproducibility on the MLOps side while still enabling the AI product team to function independently and go fast and add value, because their goals are not always quite aligned. But if you can align the MLOps team's goals, manages a product, where they're supporting the AI team to achieve their goals faster while still maintaining maintainability, reproducibility, and SOX compliance and everything else, then I think it's a win-win situation.
Yeah, definitely. Standardization, people. Really important thing. So wrapping up, this is a futuristic question. Looking ahead, what excites you most about AI featuring retail, and how can partnership help drive that vision?
Yeah, that's a great question. I love, well, I don't know if it's specifically retail, but I'm really into, how AI is going to be infused into every product. Wearables is kind of one of them. Smart kind of everything in the future, and that's kind of exciting, and how they'll interact and talk to each other. When I think about maybe retail specifically, I think about, when I think about search and personalization, today it's you're on a website, and maybe the old school search is you click on the search bar, you type in the keywords that you think represent the product. You hope they match the keywords that the retailer chose to represent the product, and then it gets ranked in a way that is maybe personalized or maybe not, and then you click on the items until you find what you like, and it sounds like AI can have a big disruptive impact there. So maybe there's a personalized experience, hyper-personalized, with maybe a digital assistant that you'll talk to, and that can help you figure out what you really want. Maybe there's multiple modalities in search. Maybe text is not always the best one, especially in the fashion world, where things are much more visual, and you want to find things that look like other things, and filter for different words, and have the search be smart enough to understand that these words also mean these other things.
Yeah, similarity.
Yeah.
Yes, of course. And that's all for my questions. Thank you very much, Chris, for being here today.
Thanks so much.
Thanks, Chris and Soledad. So,
We'll have some time from
Yeah, for questions.
okay, we have some time for questions. I had forgotten about that. I can pass on the mic. And another thing is that the bar is going to become
Kosh Bar.
cash bar at 7:30. So if you want to have a drink and not pay for it, this is the time. Questions? Questions for Chris, for Soledad?
Yeah, thank you for the fireside. Thank you for the talk, very interesting. So it seems like the RealReal, you guys have been working on a bunch of AI projects for a really long time. And you know, with the ChatGPT boom and all the LLM boom, has that changed anything in like the recent year?
Yeah, I mean, it's definitely generated a lot of excitement. Nobody wants to miss out on what could be. And I think it's caused a little bit of putting the solution before like the problem definition, which has added a little bit of spin. So rather than traditional software, ML, where you're like, okay, what do we want to solve? What's the biggest impact? What are multiple ways that can solve that thing, from very simple to very complex? And what's the best implementation to solve it? We're going a lot of the case, in my opinion now, from like, okay, here's the solution, what problems will it solve? And it's maybe not always the best thing, although it is very disruptive. Depending on the use case, if it's something core to your business, you want to maybe act right now. If it's just kind of like something that could be neat, again, I would treat it like any other technology that could be neat. Next couple years, I'm sure there'll be new technologies just like it. They'll be very disruptive. But it's very, I guess, on the other side, it's very good to have like a good knowledge base, being in the industry of like how could this be used to have this kind of conversation.
And adding one thing to that, you also need to know the limitations and the bias behind the technology, and that's something that not many people is getting into, and they are only buying the next shiny thing. So yeah, it's really also important to know what's behind the new technology. And we are also working with companies to try to teach them how to manage these kind of technologies.
More questions, you?
Yeah, it's very related also to Gen AI. So you've been working with AI before Gen AI, and so a lot of the products you have built have been using more traditional deep learning techniques, I can imagine. Looking back, if you could had access to this technology and these LLMs before, or like, is there anything that you would still go for traditional deep learning to build today? If you had access to like these large language models, or do you think that everything's going to be large language model based from now on?
I guess I don't know yet. I think a lot of things will kind of change over time, but I think there's definitely a use. When I think about where my mind's going with what could be, I often wonder now, like the straight classification where you have a set number of fixed categories, if that's always going to be the case with LLMs, or there could be more flexibility there to not have so much. Similar with Gen AI, a lot of multi-modality things that I might go back and use kind of that updated information in the past. But I don't know that there's still a use case for this today. I'll say it for today, for traditional ML approaches for sure, to have a huge impact and be faster to market and faster to impact, especially on tabular data sets, on computer vision, although there's a lot of, it just changes so rapidly. I'll say it today and then tomorrow there'll be a new approach that is that's much better. But today, yeah, there's definitely, I would not recommend LLMs in a lot of cases to go after today.
I think this is also a great setup for the next talk, which I don't want to spoil. But any other questions? Do we have time for more questions?
One more.
One more?
The CEO jogs. Now, I guess I was wondering if you're planning a core and fundamental project for your business and you're working with a third party to build a good chunk of that, how do you plan for the long-term ownership and maintenance of that work internally? or do you consider that to be a long-term payments relationship going forward?
Yeah, for our relationship when we partnered with Trio, we probably have a different relationship than I would say with the external vendor for sure. We view them alongside our internal employees. We work with them to both up-level, provide feedback, just like, I would say in our case, they're just like an internal employee, and we use them for staff and documentation. It's been more of a strategic partnership than it has a vendor relationship. If you do rely on a vendor in that kind of, probably that, what you're kind of mentioning, where it's kind of like a throw it over the fence, or like there is a large degree of separation, I do think that would be a challenge to think for the long term. And you definitely need to kind of organize a staffing strategy to do it. For us, we often found that in the market where we could get for in the Bay Area, it just made so much sense to continue this partnership, and it was very successful. And they're like, Dad, no. We are hopeless. But more seriously, I do want to thank Tryolabs. They've been a fantastic partner for us. They've been actually working and helping us build some aspects of the product that I'll show you. It's really fantastic to be here. What a great venue that they've chosen. So the LLMs question were a great lead-in into my talk. So I'm going to talk how we can sort of transform generative AI and LLMs using a neuroscience-based approach. So, these are just some of the headlines that have been coming out this year. Everyone has heard of ChatGPT, and LLMs have become a three-letter acronym that everyone knows about now. Everyone's used ChatGPT, and it's getting a tremendous amount of hype. And it sort of seems to have brought AI finally into the public consciousness. Like even my mother is sending me texts about GPT. Huge potential for transforming, almost any industry you can think of. And every boardroom across the country is now trying to figure out how to incorporate LLMs into their workflow. But when we actually talk to customers who are deploying LLMs, the picture is not quite so rosy. There are significant challenges in deploying these technologies. One of the biggest ones, as soon as you start thinking about business model and incorporating it in, you realize how expensive these models are. They're expensive to scale and deploy. GPUs, which is the primary substrate that they run on, are not available for the next year and a half. They're difficult to scale. IT is problematic with GPU-based environments. Most enterprises don't want to send their sensitive data to an external service, particularly large enterprises. They really want to have control over their data, so privacy is a really important thing. Reliability, the models can be unstable. These external services are constantly updating their models, which is great, but if you're building a business application on top of something, you can't really do it on top of shifting sand. You need something that's stable, and again, you need something that's controllable. And overall, I think that there's a lot of confusion in the market. When we talk to enterprises, the market is chaotic. It's really fast changing. It's hard even for us to keep up with it, and we're in the field, but it's really hard for most enterprises to stay in touch with it. And companies are sort of overwhelmed. When you think about cost and scalability and so on, I always like to show this slide, and everyone has seen slides like this. But what this slide shows is the tremendous amount of compute that's being required by AI systems over the last, let's say, 30 years. And if you notice, the y-axis is actually a log scale. So if you squint your eyes, there's been a 10 billion-fold increase in the amount of compute that's required by AI. And this ends at 2020, it's actually gone even higher. That's what that red curve is. Now, hardware during that time has increased quite a bit too. The blue line, it's pretty respectable. That's also an exponential curve. But as you can see, it's nowhere near the red line. So that gap between the red line and the blue line is really what's driving a lot of the cost today, because hardware just cannot keep up, and the complexity of deploying these systems. And so, we need to bring those things back into alignment
in order to make LLMs really deployable at scale and accessible. And so the question is, where do you look? How do you do that? You can't count on the hardware. You need something algorithmic and something software related. And that's where we feel the brain comes in. The brain is incredibly efficient. Our brains only use like 20 watts of power, which is less than a small light bulb. And if we can understand what's going on in the brain, maybe we can apply it to AI systems. So that's where Numenta comes in. We were founded back in 2005. We spent like 17 years focusing on neuroscience. We were created to really sit at this intersection between neuroscience and AI. We've really spent a lot of time deeply understanding the strategies that the brain uses for implementing many, many aspects of intelligent function. And our co-founder, Jeff Hawkins, he recently wrote a book describing our theories and what we've learned from the brain and how it can impact AI at kind of a high level. So if you're interested in that, definitely pick up the book. It was one of Bill Gates' top 5 books of 2021. So definitely encourage you to pick that up and read it. And so, when we look at this, and we look at the red line and that blue line, how can neuroscience really impact AI? Now, I mentioned that the brain is really efficient in how it processes stuff. So we now understand in great detail some of the strategies that the brain uses to achieve that. So I'm not going to talk too much about neuroscience. I could talk about it for hours if you want. But I want to point out 2 different things that you may not realize. So in deep learning, the neuron model is very simple. It's a linear weighted sum followed by a nonlinearity. But in the brain, neurons are much more complicated. They're very sophisticated, sparse computational devices, and they use energy very, very parsimoniously. So they're extremely efficient devices. The second thing, this works. If you look at the network level, in deep learning, everything is really brute force. You multiply everything against everything. But that's not what happens in the brain. If you look at the entire network, when you get an sensory input coming in, the brain decides dynamically what the context of that input and activates a very tiny subset of the overall brain network to actually process that input. So most of the brain, like 99.99% of the brain, is not used for any particular input. So if you're in a business context, in a meeting, in a meetup, listening to an AI talk, there may be a subset of your brain that's used. But if you're dealing with your kids and dropping them off at school, there's a completely different subset of your brain that's used. And the brain can determine that dynamically and allocate metabolic energy and compute very, very efficiently. So we can actually understand these algorithms and apply them to AI systems. So when we look at that, that's where, fast forward to 2023, we've taken a lot of our neuroscience understandings and created a product called Nupic that was just announced last month. This is a product that Tryolabs has helped develop parts of. And I'll tell you a few aspects of it. So Nupic is designed today for NLP systems. So we support many, many different NLP use cases and focusing on large language models and transformers. This diagram talks about the structure of the product. So we have an inference server, which is in the middle, which is a hardcore C++ assembly coded inference server that encapsulates our algorithms and allows you to run things really fast. We also have a training module which allows you to take your data and then customize or fine-tune the models to your application. So that increases the accuracy of the models for your specific application. So 2 important components of this. One is that this runs completely on our customers' infrastructure. These are all containerized. We talked about containers earlier. So these are all containerized and they run completely on our customers' infrastructure. We see none of the data. We don't know what models you're running, what you're fine-tuning, nothing. Everything is private to the customer. So this is a really important aspect of the product. But one of the really interesting things is that the inference server can run completely on CPUs. So today we're used to running LLMs on GPUs, but because of our neuroscience-based approaches and our optimizations, we're actually able to run these things more efficiently on CPUs than you can on NVIDIA GPUs. So how are we able to do that? So to do that, we've partnered with Intel. They've released a new instruction set called AMX, which does math operations, matrix operations, pretty fast, but it has all the benefits of a CPU. So we worked with them starting last year, and we're able to take our neuroscience-based algorithms, which don't really fit the typical GPU programming model, which is sort of very simpy if you're familiar with that. But this, with these instructions, you have the full flexibility of a CPU, plus you can farm out to math operations when you need it. And this is the next generation of Xeon servers that we're all familiar with. They were announced earlier this year. So we've been able to take our algorithms and actually map it to this hardware. And so what this chart shows is our system running BERT large on a CPU compared to the speed you can get on an NVIDIA A100 GPU. So the NVIDIA numbers are not our numbers, these are released by NVIDIA. So this is a very fair comparison. And you can see that our system is anywhere from 10x to 30x faster than just at a raw level than what you can get on an NVIDIA GPU. And when it comes to price performance, the incredible price performance benefits. So if you think about it, we think this is a really transformative moment for AI. The fact that you can now use CPUs to run AI systems much faster than GPUs is really a watershed moment. Because once you match the speeds, no one really wants to be on a GPU. GPU is a very complex programming environment. Everyone's used to programming in CPUs, and there's tons and tons of flexibility built into that. So we believe we're going to be building and ushering in that new era. So that was with BERT Large, which is a non-generative LLM. So our system also works on generative AI. So there were some questions around generative AI earlier. We think you have to use the right tool for the right job. And generative AI versus non-generative AI, it's important to kind of understand those distinctions. So what is generative AI? That's like ChatGPT or GPT-like systems. They're generating new text and new content. They're often like human-like responses. They can be quote-unquote creative. They're very flexible. So they have a lot of real advantages. But non-generative AI techniques like BERT are also incredibly powerful. They actually are best for understanding text and analyzing text and using it for various applications. It's much cheaper to run those. They can be extremely accurate, and you can really control them much better than you can a generative AI system, at least today. And so they all have pros and cons. Generative AI systems are slow and expensive, whereas BERT-like systems have trouble with long context windows and things like that. But when we look at enterprise applications, most applications actually use a combination of these things. So for generative AI, you can use it for things like translation, summarization, original chatbot responses, and so on. But if you want to classify text and analyze text and retrieve things, a non-generative system is actually really good at it. So our system works with GPT models as well. So as this chart shows, with NUPIC, you can run GPT models anywhere from 2 to 10x faster than what you can with an NVIDIA GPU. What's interesting is that once you're on CPUs, you get all of the flexibility of a CPU. I'm not going to walk you through this in too much detail, but what we're able to do is run dozens of models concurrently on the same server, completely asynchronously, with no batching required. With GPUs, to really get the speed, you need to batch, you need to higher and higher batch sizes. But when we don't have batching, when you can run things asynchronously, spin up different models on the same server, it's really simple. It's just like you run Excel and Word and Outlook on the same laptop. That's what you're used to. You can't do that with GPUs. It's really hard to run multiple large models concurrently on the same GPU. So, CPUs are, have tremendous power. You can run multiple models, like I said. They're very flexible, they're scalable. A lot of the issues that people are running into with LLMs are actually solved once you move to CPUs. But until now, it hasn't been possible to run these models on CPUs. Okay, here's sort of a typical example from one of our customers. What this shows is a chat transcript. So imagine like a customer is talking with a customer service agent using a text-based chat. In this case, the customer is really unhappy about something, so you can use NUPIC to the non-generative AI techniques to do something like sentiment analysis. You can quickly tell that the customer is really unhappy here. Maybe you need to bring in a manager or need to do something to make the customer happier. But you can use generative AI techniques on this as well. So one of the very common use cases that we see in enterprises is to take chat transcripts like that and create like a one-sentence summary of it. And this is something that can be used by managers and so on to quickly get an idea of the problems that the system that their customers are running into, or what are the customers are talking about today. It's very easy to quickly get an idea of that, which is really hard to do using any other techniques. So this, what this example shows again is that many business applications often use a combination of generative AI techniques and non-generative AI techniques. And it's really powerful to have a single product that can run across all types of models. I think I won't go into this in too much detail. It's really designed for ease of use. This shows some code snippets. It shows how easy it is to use our system. You don't need to worry about installing a lot of stuff or worrying about dependencies. You can just, everything's behind a Docker container, so you can just write simple code and run inference and do analysis on it. This is an example of call transcript summarization. In this case, it's a speech-to-text scenario. So there's a customer, we're calling in on the phone. You can see that the text is not correct, grammatically correct. And the speech recognition also has a lot of issues, but a GPT-like model can actually take this and summarize it and create a very simple summary of this. So this is another example of using generative techniques. This is probably one of our funnest customers. So if you've heard of Will Wright and Lauren, so Will Wright is famous for having created The Sims and Spore, two of the most popular games ever. He's probably one of the best game designers out there. So Will and Lauren have created this new company called Galleon Studios, and what they're doing is creating, you can think of it as an extension of Sims, but with large language models at the core of it. So what they're enabling is creating Sims that are your proxies. So that you basically tell these systems in English a little bit about yourself. You could download, quote unquote, download your memories to it using English, and then you have little proxies that act like little yous, and they go running around in the world, and they can interact with other proxies, do fun things, and of course, depending on what you tell the proxy, it's going to have very different characteristics and personalities. So you can have a dark side of yourself, you can have a fun side of yourself, a nerdy side of yourself, and so on. So anyway, the stuff that we're developing is perfect for them. And this is just an example of the creative things that people are doing with LLMs today. I can't wait to see what they come up with once this game is released. Okay, just to kind of summarize, so what Numenta is really about taking neuroscience at a very fundamental level, really taking a deep understanding of how the brain works and then applying it to AI systems. And what we've been able to do is take that as a first step to make today's transformers really, really efficient. But down the road, there's many, many new things that we can, many things about how the brain works and how we can make intelligent systems a lot more intelligent than they are today. All right, thank you. On the mobile devices. That's definitely in play. Running LLMs efficiently on their laptop is another example, or in IoT kind of devices. All of that's what we have.
How far in the future do you think it's from?
Now you want me to predict it. It's so hard to predict these things these days.
Qualcomm announced today.
Are you recorded here?
Yes, yes.
Yeah, people are. They're already starting to do this. I think Apple has released various SDKs for running LLMs on your iPhone even today. But we think, we certainly think we're going to enable much larger things running on edge and mobile devices than you could otherwise.
Question here.
Yeah, it's a bit of technical, but GPUs are known to be inherently random because some operations are stochastic in a way. And that makes that even if you run an LLM with temperature 0, you might not be guaranteed reproducibility. Is that something you can fix by running LLMs in CPUs?
Yeah, great question. That's a unique one. I've not heard that one before. But yeah, GPUs are. We're all nerds, right? So yeah, GPUs are inherently stochastic because of the way threading is done, and the timing is a little hard to predict. So on CPUs, you do have a lot of control over that. Yeah, so you could make it completely deterministic. If you really want to run at speed, though, you may still want to use multiple threads per model. So that's in Numenta, you can actually control that. So if determinism is really important, you can say, okay, just one thread per model. And actually, in the BERT large throughput numbers I showed, we were only using one thread per model in that case to get those numbers. So yeah, you can make it completely deterministic.
Thanks.
Other question?
Thanks. So you focused a lot on the cost savings of utilizing your model, and that's clearly really important. But what about making better decisions and through the neuroscience, or is the neuroscience just about getting to decisions faster, or is it really about qualitatively better decisions?
Yeah. So speed is one important aspect of it, but there's many other things about the brain that are not in today's AI systems. So one example that I like to use is something called continuous learning. So you and I are constantly learning, right? Whereas deep learning systems there's a training mode and an inference mode. There's this sort of artificial dichotomy. Well, we know a lot, and Jeff talks about this in his book, about how continuous learning is actually implemented in the brain. So that's something we publish papers on that we can incorporate into deep learning systems. And what that will enable is systems, if you use ChatGPT at all, it says, oh, as of my knowledge base of 2021, this is what I know. Like even OpenAI, Microsoft has not been able to keep ChatGPT up to date with all of their resources. So that will, that one thing will qualitatively change the nature of AI. That's going to have a dramatic impact. If you can have AI systems that are constantly learning, constantly keeping up to date with the latest stuff, I think that's going to have a huge impact. So that's just one example.
Other question?
Time for more.
Right. Okay. Thanks, Subutai. It was a very nice talk. Get some drinks. All right. We'll sit and do this. Okay, let's check. I like moving along. How's everyone doing?
Good.
I would a louder applause than like the first one. How's everyone doing? Yes. Very cool. So we are here to give a slightly different take on AI, and it is basically empowering AI with OR. First of all, before we begin, I wanted to give a huge thanks to Tryolabs and Alan for giving us this opportunity. This is awesome. Venue is awesome. We're excited to be here. Yes, you can clap. All right. So before we get into the lecture proper, who are we? Okay. We're going to start with our intros. I'm Vinod Cheriyan. I wanted to give a quick story about like how my nonlinear path to data science. So I started way in the past, but I went to IIT Bombay. I studied, of all subjects, mechanical engineering, believe it or not. Is there any mech engineers here? Oh, yes! We have some. Very cool. Okay, I thought I was a So then I graduated and I went to Deloitte. I worked there for about 5-6 years in their data warehousing group. Then I left all that and went and did a PhD in operations research. Hence, like, or in the title of the talk. At Georgia Tech. Then I joined Innova, a fintech company based out of Chicago. I was doing data science there. And last year, I started with Stitch Fix. And along the way, I've also been working at Informs. Has anybody heard of Informs? Yes, it's okay. I wasn't expecting that. Yes, it's the largest professional organization known in management sciences. Started with the Chicago chapter. Now I work, serve the Solutions Council of the National Informs. So during this very nonlinear path, like I picked up various skills and techniques that help me do good data science. And saying all this because I think many of you have had these kind of nonlinear paths. If you did, celebrate, embrace the nonlinearity in your career paths. So that is the, yeah, you can clap again. All right, over to Mark. Yes.
Yeah. Hello? Yeah.
Yeah, so my name is Mark. I've been at Stitch Fix. Sorry, I've been at Stitch Fix for.
No.
Might be low and better. Yeah, so I've been at Stitch Fix for 6 years. My path is a bit different than Vinod's. I've been trained as an astrophysicist. I'm originally from Holland. My career, I was really planning to be an astrophysicist for my whole life. I went to the US for my PhD, traveled to Australia, worked there for a couple of years, went back to the US, Germany, at these different places. Finally settled down in Norway, but it turned out I really didn't like Norway. So, you can ask me about that later, but then I finally ended up moving to California, where I landed at Stitch Fix, and I've been happy since. Most of my research focused actually on understanding the first galaxies and black holes in the universe. It's actually a very exciting time for that with James Webb Space Telescope, but I'm sort of following it as an amateur right now, and I really enjoy it. Yeah.
Cool. All right, so we also want to show our team. This is our manager, Murray, Mark and myself, and we also have a bunch of excellent alumni because all what we're going to present is joint work with all these folks. So we wanted to represent them. And the next 2 slides, I'm just going to give an executive summary because I know this is like the third talk and the people are a little tired. So, but I didn't want you all to go home without getting the gist of things. So our main message is AI is the brain and OR gives it legs. Right? So situation. Stitch Fix has a lot of data. Right? Vast amounts of data, about 10 million data points, and we have good AI that generates excellent scores that capture the customer preferences. However, we have finite inventory, we have uncertain demand, we have lead times in ordering our clothes and SKUs. And last but not least, AI cannot learn it all, right? So it cannot exactly, we still aren't there yet, match human intuition. So we have actual human stylists who basically, the AI augments the human stylist's work. So the question is, how can we make optimal use of AI-generated scores while also addressing the constrained nature of the inventory as well as the uncertainty in demand? And as you may have guessed, the answer is AI plus OR. In particular, in this talk, we're going to talk about a technique called inventory targeting and how some important incrementality scores can be computed from them that can be very helpful in running a business. So, this is the second part of the summary slide. If you didn't listen to anything else that we're going to say, if you're thinking about drinks and snacks, take away these 2 things, okay? One, without OR, you can conclude that your AI-generated scores are not good enough, right? So, because you're not actually using them to their best efficiency, and it can be less impactful. And secondly, the incrementality scores and metrics, that direction is very important in making day-to-day business decisions. And it can even help you break away from some of the negative feedback loops that can exist in the system. Those are our 2 key messages. Got it? Yeah. Okay, but please listen to the rest too. All right, so I think most people here have heard about Stitch Fix, right? Okay, I'll zip through these slides very quickly. In one line, we're the world's leading online personal styling service. We help people look their best. We save people time and trouble so that they can get a personal stylist, right? And put on these excellent outfits. At the core of Stitch Fix business model is what we call a fix. It's in the name, right? A fix is simply 5 items packed into a box. When a customer joins Stitch Fix, they create a profile, and then they order a fix, and then our stylists, along with the AI algorithms, put a fix together, send it to you. You keep what you like, and then you send the rest home. You share your feedback, and our algorithms and stylists continuously learn. And you order the next fix, and then things get better. We have a ton of data, right? So data from the client data, right? So when you create the profile, you enter some of these data points. We have data about merchandise, right? Various dimensions and aspects of that. We get feedback about items that you keep and items that you reject and price points and this, that, and the other. We also have a cool toy or a game called Style Shuffle. Mark will talk about that in a little bit. And we collect tens of billions of data points. And this just some basic stats. We were founded in 2011. We have like literally thousands of employee stylists. We have more than 3 million active clients, and we have 1.6 billion in revenue. So with that, let's jump into a little bit more details about the problem we are trying to solve.
Yeah, so Stitch Fix, I think, prides itself on combining data science with human judgment. Specifically, we have algorithms that try to help stylists successfully serve our clients. So specifically, I'm going to be talking about 2 parts of the algorithm. We have scoring and we have filtering. Right, so if you can go to the next one. So the scores that I'll be talking about are really AI generated. That's the AI part of this talk. So specifically, like for each client merchandise combination that we have, we can generate a match score. So basically, how good of a match is this particular item to this particular client? And these scores, they contain explicit features. For example, what Vinod was saying, right? The client fills out the profile. We sort of have an idea of what someone wants. The other thing is someone buys something or they don't buy it. That gives us information. We learn that way. And the second thing is we have these so-called latent features. So this is information that is learned from, well, from the checkouts and sales, but also from this game that Vinod mentioned before. If you can go to the next slide. Yeah. So one of the things, actually a lot of our clients play is this game where they just rate or whether they just say whether they like something that we show them. And people really like to play this. We limit the number of times you play to 10 per day. Actually, some people then log out and log back in. And actually, I think there's a record. There was one client that was playing, I think, for hours straight. Unbelievable, actually. But, yeah, but really, people really like to play. And so we get like a lot of ratings this way. So if you can go to the next slide, and then, oh yeah, so. These ratings are actually by themselves not very useful and maybe not as informative as an action where someone buys something or not, or whether they tell us something. But we have so much of this data that we actually, can get quite a lot of information out of it. Now if you can go to the next one, and there's a video. Yes, if you can start the video. So this is something that a colleague of ours generated. So we have these we have these latent features that we learn about from our interactions with clients, about both the clients and our merchandise, each piece of merchandise. So in this case, this latent space is a 64-dimensional space, and this is a 3D visualization of that 64-dimensional space. So what this actually shows is like how, like some of these, these tops here, for example, where in latent space they lie. And what is interesting is that we're learning similar information about clients, right? So we get an idea of sort of where in this latent space client preferences reside. So the better you can sort of constrain their preferences in the same space, the better we can be at personalization, right? So, this works quite well. Yeah, if you can go to the next one.
Yeah, and so far so good, right? AI, awesome, tons of data, we have scores, and here comes the twist in the story. The twist is, that's not enough. And I'm going to double click into a little bit more detail into that previous process, right? So this is how inventory actually gets end up into a fix, right? So there are some initial qualification steps trying to see whether stuff is generally right for the customers, and we filter out some avoided ones. And then the remaining inventory, what we call the qualified inventory, we give it to the stylist in an application called the Mix. And in the Wings application, as you can see in this screenshot here, the stylists look through the available inventory, and then they try to fill so you can see the 5 slots in here. The first one is they've selected a pair of jeans, and then the stylist selects these 5 and put it in the box and sends to the customer. There is a problem here, right? If you're paying attention in the executive summary, I said what the problem was, right? Inventory is finite. And if inventory is finite, we cannot simply give the best match item to the first customer that comes in. So here's our best, right? We should have waited or anticipated for the second customer, right? So this is like the crux of the problem here, right? So here we are using the AI generated scores, which are the preferences, with the inventory scarcity. So what we need are recommendations that respect both these things, customer preferences as well as scarcity. And now, So yeah, so how can we, the question becomes, how can we best show that appropriate subset to the stylist, right? Now if you're like me, you'll be thinking, you know what, we already have scores for the preferences. Wouldn't it be nice if I have some kind of scores that can capture the inventory scarcity, and I can additively add it to the customer preferences, and then come up with a new set of scores, which I can simply rank and sort, and then show the top whatever number of items to the stylist. Wouldn't that be awesome? Yes. So because we have the rest of the talk, of course the answer is yes, and this is where the jewels come in, and Mark is going to talk to us the details of that.
Yeah, so how is it done? So what happens? Sorry. Oh.
It's called fun.
So when the client comes up for styling for us, we typically have, for a typical client, we have thousands of choices that we could send to them. Right? But what we do in practice is that we try to make the job for stylists a little bit easier, and then we filter out what we think are low match scores for example, low match score choices. Now, typically we filter down the number of choices that stylists can choose from a few thousand to a few hundred. And what we try to do when we make these recommendations to stylists is to fold in the scarcity information. So basically what we do is we filter not using scores, the AI-generated scores, but we fold in the OR-generated scarcity metrics. So, and why we do it and how we do it. I'm just briefly going to talk about this because it's actually, it's quite a textbook problem. And I'm just only showing this equation here. This is, what we're basically doing is, we have all these matches for individual clients. We make an assignment of merchandise for each client that we know, is coming up for styling. We know when our clients are going to be styled tomorrow, the day after. We know what our merchandise is like in the warehouses. We have all this information. So what we're doing is like, okay, you're going to get these few hundred choices. You're going to get these few hundred choices. But we're going to limit the number of choices to some number n, which is written down here. But we also take into account that our inventory is not infinite, that we only know, like, we have 3 of these particular blouses, like 2 of those, for example. Right? So using that, this is like a textbook integer programming problem, right? Which, my background was not this, so this was not a textbook example for me. But like, if you open up Reddit, it really, like, it's right there. Like, it's really not a difficult problem to solve. And that's what I really like about this, because it actually has enormous value. If you can go to the next slide, right? You can solve this problem in many, many ways. And two of the things that it actually generates for you, not just like optimal solutions, optimal assignments, but it gives you measures of like, how incremental is this particular SKU, how incremental is this shirt, how incremental is that shirt. Also, interestingly, similar metrics about individual clients, right? Like, how valuable are these clients? And for example, one way to interpret is that, what this SKU dual, this lambda S parameter quantifies is, I have our warehouse, we add 1 unit of this particular blouse, how does it increase our sales the next day, right? So it's a very simple metric, very easy to interpret, but for us it has been having enormous value. So if you can go to the next slide. Does it work?
Yeah, all this is fine and dandy, Mark, but does it really work? So yes. Nice setup, right? So here's an example. So one great thing that these duals and therefore the end choice, right? So that gives us is an important lever, right? So the graph on the left, it's a theoretical result. So if you reduce the number of choices that you put in front of the stylist using this algorithm, you're actually improving the overall quality of the fixes that go out, right? So because we are putting better matched products in front of the stylist, and customers, of course, like, chances are more that they buy, so therefore the quality improves, right? So that's why the graph goes like that, decreasing choices, and then improve the quality. On the right, it comes with the cost though, right? So if I try to go all the way to the left, what happens? The stylist comes to style a client, and then they only see like 3 items, and like they're like, okay, how am I supposed to put like 5 items in? Like, even like with 10, 20 items, like they're all jeans, you want a full outfit. So there is some balancing that needs to happen, and this end choices gives us a convenient lever that on the one hand we can control or improve upon the quality of the overall fix. On the other hand, we can also improve the quality of the styling that the stylists are doing. So this is how we kind of combine like machine learning plus like the stylist intuition into putting the best fix for the client. We, of course, do experimentation, A/B testing. So here's one example of results from like our US women's business line. On all the metrics for the client outcomes, green is good. And all the metrics on the stylist outcomes, green is good. Of course, there's one that's red. What is a red? We give them reduced set of inventory to look at, right? So that as expected, right? So experiments turned out good. Also, another important thing that the inventory targeting helped was it helped reduce the variability of the inventory. So the blue curve is the before we introduced inventory targeting. The orange curve is right after, and the green curve is after it's stabilized. And you can see the blue and orange have high intraday variability in inventory. After things stabilized, the green curve has less variability, right? So in that aspect, also inventory targeting is helpful. So what did all this get us? So we got good improvement in the fixed scores. We served the customers better. We also got this important incrementality statistics, like the duals that Mark was talking about, right? And interestingly, they can be used in other decisions. Like what, Mark?
Yeah, so actually, can you go back?
Oh, you want to go back? Okay,
yes.
sorry. Yeah.
I think it's what was really cool to us is that, like from a company point of view, what we were doing is like we were actually holding back good merch from stylists, right? This was like psychologically was difficult to do because it's like how come we cannot get the high resale stuff, high magical stuff, right? Now the thing is, what we actually saw by holding back inventory, it did happen that later on, stylists that were clients that were going to be styled later during the day, because we were holding back that good merchandise, they were actually getting a better experience. This was the whole goal. And this was sort of like telling us like, using these duals, these values, these measures of scarcity, we're actually doing something really good for the clients, right? So yeah, now, yeah, if you can go. So the other thing that it did for us is, and it's still doing, like it's currently informing like our merchandise buying team, like what they should get next. And yeah, for example, and also like, we have different warehouses, we can compute like how scarce our inventory is in different warehouses, right? So we can sort of determine, well, where should this merchandise go to? Like, there's quite a few applications, but the one thing I want to focus on is on the next slide, which one I actually really like. We have these measures of scarcity, right, of inventory, which quantified by this parameter lambda. What we can actually do is like solve the problem again and say, well, what if I had only one of these particular shirts? Or, how excited would people be, or how much more would our sales boost if I would go from 1 to 2 of these shirts, right? So what this tells you is like, well, there's one client out there that really likes this shirt, right? If that score is very high. So we have like one of our, there's someone who's very enthusiastic about this particular product. The other thing is what you can do is like, at what point is there no additional value of adding additional units to our inventory, right? Like that sort of gives us a measure of like how many clients do we have in our client base that we can actually, well, make happy with this product or incrementally happy with this product, right? So we have these two measures. So this enthusiast score and this depth score. That's something that we've been working with at Stitch Fix. And if you can go to the next one. So like one sort of simplified way of viewing this is that you can create this quadrant, right? Where you have like regions of parameter space where people are very excited. There's some people that are very excited. We have a lot of clients, like in the top right. So high enthusiast, high depth score, right? But you also, and this is actually a pair of sneakers that fell in that category, and that was actually, we got a lot of these and they actually performed really well. But what I'm actually quite excited about is, for example, this quadrant right here, right? We sort of know that there are clients out there that are very excited about this particular stuff, but there's not a lot of them. So what this tells you is like, okay, we have identified that there are clients in our client base that are excited about this product. There's just not so many of them. So who are they, right? And can we get more of them? So this is something that I think we've been, exploring how we can actually use this to get new clients and expand our client base, basically. Yeah. And this is something that would not be possible without these scarcity metrics, right? If you just use a metric like success rate, you would really focus on these regions that are doing well among the majority of our clients. So, yeah.
All right, this is the last slide. Bringing it all together, right? So what we saw is that AI and associated technology is very good at capturing customer preferences, provided you have tons and tons of data, right? So that part, it does very well. However, if you have a business that actually has commodities, right? So whether it's like shirts and pants, or like, or delivering coffee, you also need to make day-to-day decisions. And in order to do that effectively, you need operations research. Right? So you can use the AI-generated scores effectively and to their full capacity and make daily decisions while respecting the customer preferences as well as like your constraints, like inventory constraints. So the bottom line is you need both, and that is our take. Thank you.
Thank you so much, Vinod and Mark. This was an awesome talk. Let me see here. I love that. I think the stylists are making a local optimum decision for each customer, but they don't have the picture of the global optimum that will maximize the happiness of every single customer. So that's where OR comes in. Is that right?
So yes, in a way, yeah, because there's a missing aspect of like the timing of this too, right? Because if you had all the customers lined up and if you had all the inventory, then yeah, we could run that full OR model and give this global optimization and give that, right? However, customers come in temporally, right? And we have to kind of wager a bit, should I give the top 5 for that particular customer now, or should I anticipate there's another customer coming? So my 2x2 example, right? So the two ladies and the two dresses. So that's what the OR part really helps, right? So which are the subsets that the stylist should focus on, so that in the long run, you are making that optimal decision for all the customers. So does that have answer?
Yeah. Okay. I love that you are using OR and AI to maximize happiness.
Yeah, thanks for the great talk. I love the idea of ML plus OR making really great business decisions. The latent space stuff was fascinating as well. I'm just curious, like how many do you see a discrete number of clusters? How many clusters of design points? And how many different types of people are there in terms of design?
Can you show the mic to make it easier to?
Yeah. Honestly, like I don't really know. It's funny, like in our company, there has been, people have sort of clustered clients sort of non-algorithmically, right? So you can sort of, based on what people fill in, say like, this is my particular style. Right? And if you cluster clients that way, that doesn't really capture the variety in clients. Yeah. But the interesting thing is, like, if you cluster clients in this 64-dimensional space, and you take, for example, the first 3 principal components, for example, right? It doesn't really do much better either, right? So it's like, like bringing down the number of dimensions to fully quantify the distribution of clients, I think it's very difficult. So I think that means that the clusters are pretty diffuse. Yeah. And maybe that's because we haven't learned. But I think it's because their preferences are sort of like not well materialized yet.
More questions?
So you mentioned the psychological difficulty of giving less much to the stylist. How did you overcome that and like convince people to try this?
Yeah, so that was experimentation. So we really had to, there was one slide which had a dial on it, right? And it sort of showed like if you, could you actually,
Can you use the GIF?
Yeah.
You should get closer to each other so you can share the mic.
So this, the blob here is sort of representing stylist happiness, right? So, and the knob was sort of representing intervention strength. So what we had to do early on is have very weak interventions where we would slowly turn on or reduce the number of choices, and then we were purely monitoring like how stylists were responding, right? So we were in constant communication with the stylist community, and if they were, beforehand we said they're probably not going to be happy, but like how much of a reduction in happiness do we tolerate, right? Well, I mean, yeah. So honestly, and we were very careful with this, right? Like we were in constant touch with them. Like if there was an issue, they would tell us, and we would basically stop or like, yeah.
I also want to add, like our philosophy.
Share the mic.
Yeah, it's just because our philosophy is not AI and ML kind of replacing humans. It's truly augmenting human decisions, right? Because as we noted earlier, right? So there are certain things, like some of our customers are like, they're 50, 60 repeat customers, right? So they ordered 50, 60 fixes, and many times they create these relationships with the stylist, and they know, yeah, their kid's birthday is coming up, like, so let me send you something that you can wear for a birthday party, right? So to that degree, right, that it's so difficult, at least as of today's technology, AI cannot like reach that stage, right? So we are very conscious about using both the strengths, right? So AI is very good for capturing these preferences in like these millions of data points, whereas human stylists are very good, like, does this jeans go with this shirt, right? At the end of the day, like a human can say, I hope it goes well. But yeah, so using that intuition, right? So we are always very receptive to what the stylist's feedback are. We have constant check-ins with the stylists, and they give us ideas, we give them ideas. So it's a very healthy relationship.
Okay.
This is great. I was kind of curious on the temporal spot about this and like how often you rerun the simulation. Do you do it every day? You mentioned that customers are coming in, but I also imagine that there's inventory that kind of comes in and maybe that comes on a fixed part. Maybe you have to forecast it. I'm not sure. So I'm kind of curious about how you operationally handle it.
Yeah. So there are, I'll take a first step and you can fill in. There are a number of details that we skimmed over. So even though the optimization problem is a textbook optimization problem, the internals are a little bit more complicated. And so the schedule, those are essentially the two things that you called out, right? So one is like the variability in like the customer arrivals. So we do some batching to kind of make these to run the optimization, right? So typically like for a daily schedule is kind of what we look at. And for the inventory arrival, we have to also do some estimation of like the inventory quantities, right? So the Q that you saw in those equations, right? And the inventory for Stitch Fix is very unique in the sense that about half our stuff is out there, like in transit to the customer or on the way back. There's still our inventory, right? So it's very difficult from like Macy's where you go online and you buy. At that moment you pay and like the inventory gets deducted, right? For us it's not like that. Like the inventory is deducted only when like the customer decides to buy it, right? So there is a lot of inventory estimation that goes behind the scenes, which enter into the QS parameter, right? So that's how both these things are taken care of. Yeah. You want to add something?
Yeah, I forgot what, but one thing that I really like about this problem too is that like that's exactly right. Like how inventory flows to and from our clients. Like we really have to sort of estimate what is going to come back over the next few days, and we solve this problem. We solve this problem daily in batch. We sort of like try to optimize over 7 days each day when we run. Now, what is interesting to me is that because the stylist is involved, we sort of have to anticipate what they're going to send, right? So we sort of have to make, if something is like, that Minx pen view that you showed, right? Like if we say we present stylists with 300 items, right? That Minx window that Vinod showed only contains like 8 items, right? So if something is ranked number 225, stylists need to really work to get to it, right? Or really need to search to get to it. So like it really matters if something is ranked, say, number 3 or like number 200, right? So you have to sort of factor this into your model as well. And it turns out sometimes we are just really bad at it, right? So this whole example where we say, oh yeah, inventory is much more constant during the day, that's true. But there's examples of like us buying some new stuff and it just flies out of the window within an hour, right? Like, so we were completely wrong about, like how much demand there was for it. So, and that's what we're trying to, compensate for, but it's been very difficult. Stylists really respond in ways that are very difficult to predict, which is great, we're learning a lot from that.
All humans.
So in inventory, you would have similar items, right? So I think, so in the 2 dress example, do you factor in, well, she likes this dress, but we don't have enough, but here's a similar one. How does that kind of factor into the processing?
Yeah, so right now it's a great question, and that's actually one of the things, the way it factors in right now is that You know, if they are very similar, they would have very similar latent features. They would have likely produced very similar scores. So right now, if one of them is scarce and the other one is not, the way we sort of account for scarcity would push the scarce one outside of the sets that we pass through, right? So, yeah. Now, then there are some clients that sort of have their preferences such that they might avoid like a certain color, right? And for those clients, the scores are actually significantly different, right? And then the scarcity correction that we apply may still cause that dress to flow through to this client that actually, right? It's remarkably like how simple this stuff is, but it works. You know?
Yeah, I have a couple of very nerdy questions, so yes, very excited about all our questions. When you showed the optimization problem, most of all your variables were binary, and so for someone like me or Alan that wear the same T-shirt like a lot, and we might be interested in getting like a lot of the same. Is that
not actually the same, maybe the same color.
How do you model that? Or is that not something that can be taken into account? And I have another one.
Yeah, it's funny, like for men's clients, this is like a question that comes back, especially for men's clients a lot. Especially like they really will want the same pants like 5 times, for example. And that's not a joke, that's really, and we're not well set up for that.
I mean, I noticed because so the actual optimization problem is discrete and it gets a lot harder if it's not like binary decision. So that's what I'm asking.
So the XCSs are binaries, right?
Yeah.
However, this is an assignment.
Get the mic, right?
Oh, yeah. So the XCSs are binary, right? So let me come to that slide. Yeah, they are binary, right? So which shirt goes to which client, right? But since it's an assignment problem, the linear relaxation works just fine, right? So you can treat them as continuous variables, and that gives you integer assignments, right? So that is like part one of what you're asking, right? So we're really solving an LP, not an IP, right? And the second part was if you have similar customers, would they get similar assignments, right? No, or what was
no, the question was like how do you represent that you might assign several of the same item to a user? Like I want 5 of the same T-shirts, so it's not just like Diego's gonna get a white T-shirt, but rather Diego should get 5 white T-shirts. And so that should also factor into the number of.
Oh, okay. Yeah. So this optimization is at the level of what we call style variance.
Yeah.
So all those five different items are like it's represented as one style, right? So, and I think like our standard assumption is that like we don't put it into a fix exactly 5 white T-shirts, and that's not really a good fit, right? So in 5 different colors maybe, but that's how we optimize at the style variant level, not at the actual SKU level.
Yeah, so I might have an issue using Stitch Fix.
If you want 5 white T-shirts, you can go to. We also have a freestyle kind of. you just go.
Why would you need a stylist if you just have only one stylist?
But that happened actually.
Yeah.